everybody. Well, I can't welcome everybody because everybody's not here. Welcome those of you who have made it so far. It's just now 8 o'clock straight up. So we got people rushing in our virtual door. So, how was the math module? Hmm. I see I got a lot of those to grade. If you've turned it in, I haven't looked at any of them yet. So, I know nothing about your math module. I have not looked at any of them. But I see there's a stack of them to grade. And then I imagine there's some. I've had some people email me and say, "Man, I'm having some trouble. Can you help me?" And that's great. I'm ready to do that as well. Uh, so looking at that. But if you have not got it turned in yet and need help, let me know, and you can come to class Wednesday or this week is a Friday a day, Wednesday or Friday as well. Even if your grade's above 70, you don't have to be here. You can still come and say, okay, Mr. Brock, I'm having trouble with this math module. Can you help me? And then when I'm done helping you, you can leave because if your grade's over 70%, you don't have to be here to start with. So you could always pop in class and say, help me, help me. So that is available as well. Nice to see your lovely faces this morning, ready for another day. So let me get this screen ready to pull up here. Okay. All right. Now we got it. All right. So welcome to Monday. Welcome to the last week of October. Seems like we just had the first week of October. Wow. October has just zipped right on by. So next thing you know, it'll be end of the semester and then we'll all be panicking. No, we won't all be panicking. A lot of you guys are right on top of everything. Doing a great job. Doing a great job. Let's pull up our curriculum and see what we're looking at for the week. All right. I can see that I have not turned in my assignment. Let's see, my grade is down. I did not get the math module turned in. Like I said, I hadn't even looked at it, so I hadn't turned it in myself. I'll get mine turned in. But the November 2nd assignment, wow, this Sunday is November 2nd, is 2.04, the software development lifecycle. This is not a program this week. Not a program. We just have a 5-question quiz. Next week, we'll have a program to wrap up module. Instead of a test this time, we have a program, but that's next week. Next week, we're going to do the software development lifecycle this week. So let's switch over and take a look at 2.04. I need to do my math module. I love that one. The programming process. The thing about writing really great programs is the writing part is only one step in the process. Right? There's a methodical approach that all programmers grow to learn, learn to love, love to hate. Programmers work to create and solve all kinds of different problems. What they do is different, but how they do it remains the same. It's steadfast. You know the saying, there's a method to the madness? Today, we're going to look at the method. All right, so after completing this lesson, we're going to be able to understand the steps, documentation, and tools used in the standard software development lifecycle, SDLC. That's what we're looking at this week. We're going to learn to select the appropriate model to use in software development projects, recognize tasks performed and tools used by programmers to release software updates, and understand the need for ongoing program maintenance and methods used to facilitate changes and version control. Let's look at page 2. All right, the development lifecycle. As you've already realized, programming can be complicated, and we've just done very basic programs. That's why it's important to have a plan. I like these 2 pictures. Code doesn't work. I have no idea why. Whoa, that code works. I have no idea why. Yeah, that's often the life of a programmer. Yeah, very, very good. Programmers call their plan the software development lifecycle. That is also sometimes called the application development lifecycle, or sometimes the software development process. So it's got a few different names. But this is basically the fully planned out life of a project, from its early ideas and planning to its execution and delivery. So without a software development lifecycle, programmers can get stuck wondering why things aren't working. Remember, it's always smart to have a plan. So here's the steps. Generally, the SDLC has 5 steps. Let's take a look at each one to understand how they help programmers do their jobs better. And while the SDLC obviously applies to software, we can actually apply the steps to any project. So for this explanation, we're going to use bicycles. The software development lifecycle explained with bicycles. So step one is planning and analysis. So the first step is where you define your project goal. What am I going to do? What's this project going to be? Create the requirements document, which is like our pseudocode, and analyze the scope. Oh, no, the requirements document's like the template that I create. Here's the requirements. Here's what I got to have. And then we'll analyze the scope of work. So with a bicycle, that would be figure out what a bike needs to work. It needs wheels, handles, a seat, some gears, etc. Right? Find out where you can buy the parts, how long it'll take to get the parts, who's going to build this bike if we get the parts, and where we're going to sell it. See, this is like the planning and analysis stage. We do the same thing with programs. So the design, this is where we write our pseudocode. Design your program by writing the pseudocode and kind of mocking up how the software is going to work and what will it look like. So over here is where we sketch out our bike. We draw the two wheels, the manual pedals, the handlebars, include a little bell in your storage basket. Ding, ding, ding. So you plan out and sketch out your bike. Then part through is the actual coding. Part three is the actual coding. This is where you actually write the code. And over here with bicycles, it's where you actually build the bike. Then step 4 is testing. This step includes identifying defects and debugging to make sure your software is running in tip-top shape. If it has inputs, you're going to run the program and put in different inputs to see if you can create an error somewhere. If I put in this, will it be an error? Nope, that works. If I put in this, will it be an error? Nope, that works. Testing your program. And does it actually produce the right results? Over here, there'll be see if the bike actually works. Pedal slowly, pedal fast. Make a U-turn, try out the brakes, make sure the seat's comfy, and don't forget to test your little bell. Ding, ding. Maintenance. This primarily involves updating and making improvements based on user feedback. Because a lot of times you'll release a program and the user says, oh, that's great. Could the program do this also? And you're like, oh, yeah, I guess it could do that. Then you go back and you update your program to add more functionality to it. And of course, resolving any defects. The user may say, hey, when I enter this, it gives me an error. So, oh, let me go fix that. So you'll update your program, make improvements. The bicycle, your test users have mentioned sticky gears and the brakes are not reliable. Sometimes they slam into the wall. Those are big problems. So you tweak the design. Oh, let me make the gears work better by changing the design. Let's change the brakes to do this. We'll update the user manuals as needed. So this is the software development lifecycle. You plan, you design, you code it, you test it, and then you have maintenance to make sure anything that pops up. So see below to learn more about the software development lifecycle, including why it's important, what necessary documentation you need, why it's crucial for creating successful programs. All right, let's look at the steps down here again. Step 1, planning and analysis. So the planning and analysis step kicks off every SLDC. The team defines the project goals. All right, let's get together and figure out what is the goal of this program. What's it going to do? Create the requirements document that outlines what's needed. Okay, the program needs to do this, it needs to do this, it needs to do this. Analysis includes looking into the budgets, the timeline, the resources, and the existing technology. Is there already a program that's doing this? Do we need to write a program? How long will it take? What's the timeline? How long? What resources do we need? Well, our computers we have sufficient? Is there something we need to upgrade? What's the budget? Like, if it's going to take this long, it's going to take this many hours to program. It's going to cost this much labor. Do we have that much of a budget to write this? In other words, you plan it before you do it. This saves tons of time and prevents wasted effort. Let's look at the design. Step 2. So rather than jump right into writing code, okay, we know what the program needs to do, let's write it. No, programmers use this step to write the pseudocode. All right, let's design this and think through all the steps that we need to do for this to work. Helps them think through their entire process and make sure the logic is sound. It's like, oh, wait a minute, if we did that, we never defined that. We didn't, that doesn't even exist. We need to go back and update our pseudocode because we can't even use that variable. We never made it. Where they provide mock-ups of what the software looked like, how it should work. They record everything in a program design document for future reference. So if you need to go back later, oh, I don't even remember when we wrote that program. Does it do this? Let me go back and look at my pseudocode and my plan on that to see, was it even something we looked at? Did we even consider that? Step 3, the coding. This is where the magic happens. Well, yeah, it's where the programmers actually write the code. Once design documents are received, the programmer breaks the work into chunks and begins writing the program. First, let's do this. This is the inputs. Let's write that. As the programmer writes the code, he or she includes comments to explain the purpose of each part. Okay, here's the input part. Here's the calculations. Here's the output. And then the testing. Step 4, testing. Did we mention the test plan? Yeah, there's a test plan. This documents what and when something was tested, how it was resolved, and who tested it. Okay, I entered this, and here's all the data I'm testing. I'm going to run the program and see if all that works. Testing promptly exterminates all identifiable bugs. There may be bugs that pop up later. During this step, programmers report all bugs pronto and fix them to make sure the software runs as expected. In step 5, the maintenance. This stage is what makes this process truly a cycle, because it involves continued code maintenance, going back and checking for missed bugs, making design and functionality improvements. We've got to go back to the design and say, oh, we didn't make the program do that. Now the customer's asking for it to do that. Let me go back and see where that fits in the design so I can write the code and kind of starting over. Make improvements based on user feedback. Implementation of new requirements. Oh, now the program needs to do this. Let's go back to the start. User support. The team documents all maintenance-related work to ensure the software is operating at optimum levels. So your programs always need some maintenance, that update that comes out. Software development models. When two people say they love music, they could mean totally different things. One could be a diehard hip hop fan, while the other is obsessed with that YouTube heartthrob turned cheesy pop icon person. These artists do things differently in their live performances, but they both get the job done. They make their fans happy. So software development life cycles also use different methods to get the job done. Two of the most common are known as the waterfall and the agile. For some projects of people, one might work better than the other one. You got to understand how they work to know which one you want to pick. So let's take a quick look at some of the similarities and differences of waterfall and agile methods. So with the waterfall method, the programming task details. Project teams work on one step at a time. All right, we're gonna work on the input section. Let's get all that done. And we're not going to move to the next step until this step's completed and approved. Let's test all the inputs. All the inputs work. There's no errors there. We got everything we need. Great. Now let's move on to the calculations. Extensive documentation is required to keep everybody on track. This documentation allows teams to keep control over what version of the project they're working on, what changes are needed, and what step of the SDLC they're in. Now, the benefits of that is the process is very clear from beginning to end. All right, we're gonna work on the input. It's done. It's tested. Great. Now we're all going to move to the inputs. The drawbacks: if a change is needed from a previous step, the project process can get seriously delayed. Wait a minute, we're delayed, guys, because we can't work anymore on calculations. We've got to go back. We found a problem with the input, something we forgot to put in there. Backs everybody up. The agile method, as opposed to the waterfall, project teams do smaller portions of the entire project in small sprints. Like, hey, I'll work on the input if you want to work on the calculations, and hey, Joe, you work on the output. Teams can interact to handle different steps simultaneously if needed. Documentation is still required to keep everybody on track, because whoever's doing the calculations needs to know what variables I used on the input. So this documentation allows teams to keep control over what version of the project they're working on, how the project's changed. Maybe you contact me and go, hey, the calculations, I need this variable. Oh, let me add that to the input because I didn't ask for that. As an approach to rapid development, so rapid development refers to an approach that puts a larger emphasis on development than planning. Allows the project to evolve and adapt as it's built. You don't spend as much time planning because you want to jump into the coding, but you do have a plan. So focus on development rather than planning. So the process may become confusing at times when people jump back and forth among the steps. Wait a minute. Oh, wait, we need to go back and add this. Hold on. Let me test it. Wait, that doesn't work. Let me go back. We need to fix it. Because you're kind of working on everything at the same time with the agile. Or waterfall, we get everything nailed down before we move on. The methodology choice. The type of methodology you choose depends on the type of project, as does the programming language. However, some languages lend themselves more readily to rapid development. For instance, like Python or Java have more robust libraries or tools built into them that offer programmers more functionality and flexibility. So some languages also allow you to easily reuse different parts of your code, making them ideal for rapid development. Why? Because software reuse can save a ton of time. So while programming languages can aid in rapid development, it's still dependent on completing all the steps in the SDLC. So without proper planning or testing, you could rapidly develop a project, but there's a good chance it may be full of bugs. Page 4. When does it end? Well, actually, it really doesn't. That's why it's called a cycle. Go back through the cycle. Programmers don't usually ditch projects as soon as they're out the door. All right, program's done. I'm on to the next thing. Once programmers release software to the public, then their focus is usually ongoing maintenance. Right? That's why you always get those updates on those apps on your phone. Those programs have ongoing maintenance. So have you ever seen a notification on your phone, an update is available for one of your apps? That is one of the many examples of ongoing maintenance programmers handle on a regular basis. All these updates you get on your computer, your Chromebook, it'll say update is available. That's programmers doing ongoing maintenance to keep the program working right and fix errors and add new functionality. So why do they do this? There's two frequent reasons. Bugs. This is actually not as common as you might think, but unfortunately, it does happen, and programmers have to be ready to correct any glitches that might occur in their software. Having your favorite app crash on you at that crucial moment, it's the worst. Enhancements. The largest portions of maintenance work is enhancements. It seems we're never happy with our software as it is. We always want it to be better, and programmers have to come up with new ways to meet our demands. Have you ever thought, man, this game would be perfect if only. Well, send a message to the programmer. You might get your wish. That's how a lot of these updates come, is feedback from the users. Feedback. Programming trivia. How much was the most expensive bug? Ooh, give that a thought. Get a number in your head, and then we'll look. Because yes, it costs money to go back and fix errors in your programs sometimes. Downtime, stuff like that. Let's talk about the most expensive bug. 10 billion. Was that close to the number you had in your head? Billion with a B. Think bugs are no big deal? Tell that to the northeastern US. In 2003, a glitch caused multiple power systems to overload data access and caused a total blackout. Programmers had to sift through millions of lines of code to find the bug, cost them about $10 billion in lost time and damages that caused people and all the power blacked out because of an error in millions of lines of programming code. It's a pretty expensive bug. In other words, ongoing maintenance lets programmers update their software so users can continue to enjoy it for a long time to come. These updates might come through email, push notifications, those little pop-up notices you get on your phone, or version upgrades. For the user, it's usually just as simple as pressing an update button when the programmer sends a change. Some updates even happen in the background as the computer's running and you don't even know about it. Here they got a little picture of update, like you see on your phone on My Apps and Data. All these things are waiting on an update. Two major concerns of programmers in any SDLC are version control, keeping good organization through different versions, and change management, keeping documentation about changes that are needed and changes that are made throughout the development lifecycle. Version control is important because a program may go through many different iterations during its lifecycle. When a game gets a new level or your social media app gets better messaging capability, the programmers must keep track of both the old and the new versions. So with this organization, it's much easier to fix problems that might happen during updates. Change management means programmers are keeping strong notes about what changes are needed for the future. Oh, next update, we need to make the program do this, as well as what changes have already been implemented. Oh, this was done in February. Yeah. This can be important when the team is reviewing what it spends its time working on. So even though every good programming team has a plan to keep these things in mind, it may not carry out its plans in the same way. There are many methods for implementing the SDLC, and teams have to choose the development method that works best for them. All right, that is the end of our lesson for the week. Let's look at our quiz. What is the Agile method? Oh, that's one of the first things we looked at. Tyra is using the software development lifecycle to create a new game. After debugging and documenting, she released it to her friends and got feedback. So which stage is next? What's after the debugging and documenting and then releasing it? Jasmine's using the software development lifecycle to create a songwriting app. She debugged and documented for releasing. What should she do next? What's an effective way to record change management? Java and Python are considered rapid development programming languages. True or false? So you may have questions that are different. Remember, it has different questions for different people because it has a bank of questions it pulls from. But that is it. We're just looking at the software development lifecycle. We'll kind of use that and talk about our programs going forward some. But just some questions on that. This gives you a chance if you're missing a program, it's a good week to get caught up because this shouldn't take you long for those 5 questions, as long as you pay attention during the lesson or don't need to go back and review the lesson wherever you stand. So, all right, everybody, I will let you have the rest of this class period to get this done. Then you'll be ready for your next class. Anyone that needs help with the 1.05 program wants to hang around, we can talk about that. And otherwise, have a great week.